So what can we take out of 25 and 45? We can take out a 5. Then, paying attention, we have D5 and D1. And I realize that some people are not as great with this because they don't realize, or that's D4. They don't realize what this actually is. So this is the same, if you want to know, as 25 times D, 2, 3, 4, 5, plus 45 times D, 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 D. That's actually the same. So how many D's can I take out of both of them? 4. It's always the smallest amount because you have to be able to take it out of both, correct? So this one has 5 D's, this one has 4 D's, so I can take 4 D's out of both. It has to come out of both, just like 5 could come out of both number. I take the smallest exponent because it's the one that comes out of both, so D4. So you see that? That's a GCF. That's what I can take out. Everyone should be writing that down. So I have 5D4. We agree?
But it looks like D1.
It's a 4. It's a look on your paper. This thing got all gritty. I don't know why when it printed, but it does look like a 1. I thought that at first too. Okay, so it's 45D4. Now, I can take a 5 out. So now I'm going to do a square bracket or a round bracket. I don't really care what bracket you pick. You should write a bracket down. And now we're going to say, what can we take out? So we go 25 and we took out a 5. When we take out a GCF, it's always division. GCFs are always division. Because if you want to put them back in, you multiply, correct? So if you're taking them out, you're dividing. So 25 take out a 5. 25 divided by 5 is 5. And then I took 4 D's out of D5. How many D's are left? 1. So I write a D. Now, I can check my math. If I distribute it back in, I should get the number, correct? So 5 times 5 is 25. D4 and D1 is D5. So I'm good. I didn't make a mistake. Okay? Then I put a plus sign. Now I do the same to the next one. 45 divided by 5 is 9. D4 divided by D4, it's just gone, right? D4 divided by D4, I take out all the 4's, right, Ryan? And then I'm left with nothing. They're all gone. So put a bracket. Now, we're going to distribute and see if we get that. So 5 times 5 is 25D to the 5, so yep. 5 times 9 is 45D to the 4. So if I distributed it back, I should get my original. Did I? So I'm good. Done. Now B is 9K to the 4. The 4. 12K to the 3, and then this would be K to the 1. It doesn't have an exponent. So now I look at those 3 terms. Everyone's looking at B? I look at B, and I have a 9, a 12, and a 6. A 9, a 12, and a 6. What can I take out of 9, 12, and 6? 3. So I'm going to go equal sign, because this should be equal to this. Remember, I distributed this back, and I got the first part, right? That's why I put that equal sign, because the first equals the second. Now I take out a 3. Now the 9 has a K4, so it has 4 Ks. The 12 has 3 Ks, and the 6 has 1 K. So how many Ks can I take out of all 3 terms? Just 1. I have to take out the smallest amount. So I have a K4, a K3, and a K. I can only take out a K out of each of them. So I have to take out the smallest one. I can do a square bracket or a round bracket, it doesn't matter. Now I'm going to look at each term. Now this is the key thing. When you take a GCF out of 3 terms, in the brackets you should still have 3 terms because you're keeping the same amount of terms. So when you take out a GCF, you're always left with the same number. So here I took 5D4 out, but I was still left with 2 terms because there was 2 terms. If I take a 3K out, that's great, but I took it out of 3 terms, so in the bracket I'm still going to have 3 terms. So if I take a 3 out of 9, what am I left with? 9 divided by 3 is? 3. And then I take 1K out of 4 Ks. How many Ks are left? I just hit it with my ponytail. I take 1K out of 4 Ks. I'm left with K to the 3. Plus 12 divided by 3 is? 4. K to the 3, take out a K. K to the 2. And then a minus sign. 6 divided by 3 is? 2, and then a k, take out a k. Oh, I did it again. K's are out. No k's left. And now, before I box it, I distribute and see if I get back what I had. Right? So I go 3k times 3k cubed, 9k4. That's good.
Wouldn't it, if k times k3, wouldn't that be just k3?
When you have two bases with the same exponent, you add exponents. So this would be a k1 and a k3, so now I have 4 k's. Because when you have two bases that are the same, you add your exponents. And then I have 3 times 4 is 12. 1k plus 2 more k's is k3. And then 3 times negative 2 is 6 with a k. So I got it right. You guys try C and D. What can I take out of C?
2.
A 2 and x squared and x. I can take out a x. Can I do a bracket? 8 divided by 2 is 4. X squared, take out an x. X. Then a plus sign in the middle. 10 divided by 2 is 5. X, take out an x. Gone. Put it back in and see if you get the same thing. 2x times 4x is 8x squared. 2x times 5 is 10x. So I know I'm right. What can I take out?
Simplified as it gets.
Yep. Because we don't have to be trying to make it accurate. D, what can I take out?
4.
Yeah. 12 divided by 4 is
3.
3. Y, because I can't take a y out because both of them don't have it. Minus 16 divided by 4 is 4. And then I can distribute it back in my head to see if I get it right. 4 times 3y is 12y. 4 times negative 4 is negative 16, which is good. I'm going to have you work on the other ones, but in a second. F. Let's look at F for a second because everyone gets stuck here. And you should get stuck there. What can I take out of a 13 and a 20? 1. So essentially nothing because 1 isn't going to change anything. And what can I take out of an A and a B? Nothing. This one is as low as it goes. Box and move on.
Sneaky.
Sneaky, sneaky, sir. Okay, you guys are going to try E, G, H, I, J, K. Look at all these. And L. All of them. E, the biggest thing you can take out of E is not 5.
It's negative.
Not negative 5.
It's D.
It's, someone just said it. 15. Sure. So up here, the E, you could take out a what? You could take out a 15, or you could take out a negative 15. If it leads with a negative, I often take out the negative. So I'm going to go negative 15, and then I have D4 and D cubed, so I can take out 3 Ds. That's the biggest I could take out. If I take a negative 15 out of negative 15, I'm left with positive 1, which I don't have to write, but I'm writing it to prove a point. And then D5 take out D3, I'm left with D squared. Plus 45 divided by negative 15 actually makes it be a negative, right? So I can go plus a minus, or I can just write it as minus 3. So remember, when you take a negative out, it actually just changes the signs of all the terms, right? So the first term became positive, the second term became negative. With F, we said we couldn't take anything out. With G, all we could take out is a C. Make sure you have equal signs running down the left-hand side. If you're someone who's not doing that, make sure you're putting equal signs. So I can take out a C. If I take a C out of C cubed, I'm left with C squared. Plus C squared, take out a C, I'm left with C. Minus sign. What's a C divided by C? It's 1. Because if I drew it out, C divided by C, they cancel off and they make a really big 1. And it has to be a 1 because if I go to distribute the C back in, I need to get my original, correct? If I knock this down to 2 terms, if I distribute a C and I'm only going to get 2 terms back, I won't get back the original. So you can always catch if you're going to make a mistake by checking if, when you distribute it back, you get the same thing again. So I get C cubed, C squared, minus C. This one I can take out a 6. I can't take out any n's because every term doesn't have an n. So I take a 6 out, and I'm left with n squared. 30 minus 6 is 5n. 42 divided by 6 is 7. I have 7, 10, and 17. There's nothing I can take out of that. M squared, M, and nothing. There's nothing I can take out of that. So you can either box it, or you could take a -1 out of all of them. And the only reason why you would do that is if in rationals we need to like match them. Sometimes that's taking -1s out. So I'm going to show what, if I took a -1 out, what it would do. But if you just box it, that's fine as well. So if I take a -1 out, I'm going to be left with positive 7m squared. Take a -10 out, I'm going to get positive 10m. And then take 17 divided by -1 is -17. Had you just boxed it, you would have been totally fine. There was nothing wrong with that. Now, J, I have 18, 63, and 9. What can I take out? A 9. And then p cubed, p squared, and p? Just a p. So I go 18 divided by 9 is 2. P cubed, take out a p is p squared. Then -63 divided by 9 is -7. P squared, take out a p is p. And then -9 divided by -9 is -1. P take out a p is done. So make sure you have this 1 at the back, because when I distribute that 9p back in, I need to distribute it into 3 terms because there's 3 terms up there. So that's why when I say when you take a GCF out, what you have in that bracket should be the same number of terms as you have above. Now, K. I'm going to have you look at K after we do L, because K has something leading us into the next lesson. So make sure your phones are away. We have 150 and 75. What can I take out of all 3 of them? 25. So I have an equal sign running down the left. Make sure you do as well. And then I have Z9, Z6, Z5. Take a Z to the 5 out. And then 100 divided by 25 is 4. Z9, take out Z5, you subtract when they have the same base and you divide. So it's Z to the 4. Plus 50 divided by 25 is 2. Z6, take out a Z5 is Z. Minus 75 divided by 25 is 3. Z5, Z5 cancels off. So we're left with this. Now, K actually leads us into the next lesson, which all of you have learned already. The next part of the lesson, this is all review. Everything we're doing right now is grade 10 and 11 review. So if we look at K, I could take out a 2. Most people spotted that, right? And I can take out any other variables, but I could take out a 2. So most of you will have 2, 9x squared, and then minus 50 divided by 2 is 25y squared. Most people will have that. And then you guys would have boxed it, because we haven't talked about difference of squares yet. Well, difference of squares, what a difference of squares is, paying attention, is that you have to have a different sign between them. So I have a subtraction sign, do you see that? And they have to be a difference of squares. So the other 2 things on both sides of it have to be perfect squares. So what does that mean? That means if I take the square root of this one, 9x squared, what do I get?
3x.
3x. I don't get any decimals, do I? So that's perfect square. Do you see that? And then 25y squared, if I take the square root of that, I get 5y. Do I get any decimals? No. So is that a perfect square as well? So is this a difference, a subtraction of squares? It is. If you can spot that, that's the hardest factoring we do. So I'm going to go to 2 brackets. This factors into 2 brackets. The front of the bracket is going to be whatever the square root is of this one. So what's the square root of 9x squared? It's 3x. So that's going to go at the front of each bracket. And the square root of 25y squared is 5y. That's going to go at the back of each bracket. And then I get opposite signs in the middle, so plus or minus. And I actually did a difference of squares. So you see how you can spot it? It's actually named quite well. It's a difference, subtraction of squares. And we don't have to do any trinomial factoring, which is nice. So the second side is what? What's the back side of this one? Factoring by difference of squares. So we're doing the only other thing we need to know before going into rationals. So step 1, decide it's the 4 terms of anything in common, etc., etc., etc. Factor, and then you get this. Those are the steps if you want to look at them. But we have went over it. The hardest thing about a difference of squares is spotting it. Make sure your phones are away. So, How do you spot a difference of squares? It has to have two terms.
And a minus in
And a minus sign in the middle. And if it has that, then you check if the numbers on both sides are perfect squares. If they're not, it's not a difference of squares. All you can do is GCF. Okay? So I see two terms. That's what I need to look for first. Two terms with a different sign. Do I have two terms and a different sign for A?
Yes.
Yes. So I have two terms and a different sign. So I'm going to see if it actually is a difference of squares. So two terms and a different sign. And now I need to check if I square root both of them, do I get decimals? So I square root the b squared and I get b. I square root the 64 and I get 8. Does everyone see that? So, do I have a difference of two squares? Is there a difference of two squares? Yes. Once I've spotted that, the rest of this is really easy. You go right to two brackets. B goes at the front. Square root of 64 is 8, goes at the back. And then your two factors have opposite signs, so plus or minus, or you can go minus plus. It doesn't really matter. They just have to be opposite signs. So B, we have to spot, is it a difference of squares? It needs to have two terms and a different sign first off. Does it have two terms and a different sign? Two terms and a different sign? Yes. Then we check and see if these are perfect squares. Square root of a squared is? A. Square root of 144? 12. So is it a difference of two squares? Is it a difference of two squares? Yes. Because it's a difference of two perfect squares. If I get decimals when I take the square root, there's not a difference of squares. All I can do is take out a GCF. So I get two brackets. I get an A at the front of each bracket, a 12 at the back of each bracket, and then a plus or minus sign. Try these four. I'm not giving you a ton of time because you shouldn't need a ton of time, but I'll walk around and make sure everyone's getting it done. Then we're going to go over it. Alrighty, so I have two terms, paying attention, make sure your phones are away. I have two terms with a different sign. Then I take the square root of 9a squared, I get 3a. I take the square root of 121, I get 11. So my two factors are going to be 3a plus 11, 3a minus 11. D, I take the square root of x squared, I get x. I take the square root of 81, I get 9. So I'm going to get x plus 9, x minus 9. So I'm going to take the square root of 324a squared. What's the square root of 324? 18. Square root of 289?
17.
So I'm going to get 18a minus 17, 18a plus 17. Now this one, I take the square root of 81 and I get 9. The square root of m squared, I get m. So I'm going to get 9 plus m, 9 minus m. Okay, and then G, I have 25x squared minus 1. If I take the square root of 25, I get 5x. The square root of 1 is a 1. Now, often people won't actually notice this one is a difference of squares when one of the terms is 1. People don't spot it as often as a perfect square because they forget the square root of 1 is 1. So you're going to get 5x plus 1, 5x minus 1. Now, the key thing, before we do a difference of squares question, we should always, always, always check for GCFs. My goodness. So, if I have 4x squared minus 36, can I take anything out of 4x squared minus 36 first? Yeah.
Is it 4 out?
You take a 4 out. So we always have to look for GCFs first, or we're going to make ourselves more work. So I take the 4 out, and I'm left with x squared minus 9. Now is x squared minus 9 a difference of squares? What?
Yes.
Yeah, it is.
What is happening there?
I just took a 4 out.
You did it wrong.
No, I didn't.
It's 4 times 9.
So then, I get 4. Square root of x squared is x. Square root of 9 is 3. So you get x plus 3, x minus 3. Now I'm going to show you, if you actually did it wrong, how you could have made it right. So if you didn't spot to take out the GCF first, which you wouldn't have, because you probably would have saw this as a perfect square right off the bat.
Yeah.
So we have 4x squared.
Oh.
There we go, I'm not wrong, see? 4x squared, if I take that out, I'm left with a 2x. 36, I take that out, I'm left with a 6. So now I actually have 2x plus 6, 2x minus 6. And they're not as low as they can go. What can I take out of each of those brackets? A 2.
Oh. Yeah.
Light bulb moment. So, we take a 2 out of the first bracket, I'm left with x plus 3. Take a 2 out of the second bracket, I'm left with x minus 3. And the 2's join together at the front to make a 4. So you end up with the same answer if you didn't spot the GCF. You just made it harder for yourself.
I did it wrong.
Who's saying that?
You did it right.
All right.